Good morning, Year 5. Welcome back after a restful and productive half-term, I hope. Today we are back with our unit on properties and change of materials for science, and we'll continue with geography on Tuesdays as normal for the remainder of home learning. So you'll be glad to know we're back to science, back to an experiment, and something you will have the opportunity to look at later on after this lesson. So our WALT, or our question for this lesson, is which type of sugar dissolves the most in water? And today is Monday the 22nd of February 2021. So if you want to pause the video here, write your WALT and your date onto your book, then please do, and then we will get started on our do now. Okay, so as always, we'll begin with our knowledge quiz. It is in the home learning file, as always, for you to print out if you like, or you can just simply write down the answers on a piece of paper, which is also absolutely fine. So pause the video here, complete the knowledge quiz, and then we will go through it together in a moment. So our current unit, like I said, is properties and change of materials. So what are materials that do dissolve in water called? They are soluble. What is the change of state from liquid to solid known as? It is freezing. Number 3. When a solvent cannot longer dissolve any more of the solid, the solution is known as being what? It is known as being saturated. Okay, so well done if you got all 3 on our current unit. Our last unit, back before Christmas. What is the process where friction in water stops things from moving quickly? And that is called water resistance. And then back to last year, if you can remember this far back, hopefully you can. What type of tooth is used to cut food like scissors before swallowing? And it is your incisors. Okay, so well done if you got all 5 correct. Any you got incorrect, make sure you tick or fix before uploading to Seesaw, and then we will get started on today's lesson. So our lesson is which type of sugar dissolves the fastest. So we'll be looking at a range of sugars. I'll be modelling the experiment with you, and we will be encountering lots of different vocabulary, some that we've met before, some that we haven't, and we'll be revising that as we go. Okay, so a quick check, as I know it's now been probably 3 to 4 weeks since your last science lesson, between half term and covering our biomes and climates unit in geography. Just a quick check. Can you remember what soluble means? Okay, well done if you said that it is a solid that dissolves in a liquid and is transparent. So soluble means that the solid can dissolve in the liquid and is transparent or see-through. Based on that answer, what does insoluble mean? Yeah, so exactly, insoluble would be a solid that does not dissolve in water and isn't transparent, it is not see-through. Okay, so well done on those 2. We have a couple more questions just to check what you can remember. There's a clue in this picture. This picture will help you answer the question, what does solvent mean? Okay, just think for a second, what does solvent mean? Yeah, so solvent, as you can see from the picture, is the liquid, or the water in this case, in which you put your solid into. Therefore, what does solute mean? Exactly, so solute is the solid that you put into the solvent that hopefully will be soluble or insoluble when you experiment. So in this case here you can see the solute is the sugar, the solvent is the water, and then you get a solution when you put the 2 of them together. Okay, great work and well done for remembering all those tricky words from before the half term. So today is going to be mainly about an experiment. We have a couple of new pieces of information to learn, which we'll talk about in a moment, but firstly I'm going to explain the experiment that we're doing. So we are going to drop 3 different types of sugar into hot water and time how long they take to dissolve. Okay, so it's something that we've done in the past with one sugar, but now we're going to be comparing other sugars, and I've left space for more than 3 types of sugar. If you have more than 3 types of sugar at home and you want to do this, then there's enough space in the results sheet for you to do that. If you do not even have 3 types of sugar at home, you do not need to worry. You can just do 1 or 2, or you can just watch the experiment. Now, I'm going to give the disclaimer now, like I did before the half term, that this experiment does involve hot water. So please Do not undertake it unless you have an adult there to supervise you. Okay, really important. If there is no adult there to supervise you, then just please watch the video and you'll be able to do the experiment alongside me. So we have our method here to the experiment. We're going to have to measure 15 teaspoons of hot water into 3 different beakers. Okay, we don't need to do that now, but I'm just thinking about what I will need. We're going to have to place 2 teaspoons of any sugar in 1 cup, while the other person, okay, it's going to be you or a family member, get ready to time how long it takes to dissolve. Okay, so you do that with 1 sugar, then you repeat step 2 with your other 2 types of sugar, and you record how long it takes to fully dissolve. Then you repeat the experiment with cold water. So we're going to add in cold water to compare hot versus cold. Now we kind of discussed that before half term about the molecular action and how fast the molecules are moving because of the energy they had in hot water. So hopefully that will help you with your experiment and as we go and compare. So, as I said, there's a little bit of new knowledge we do need to cover before we go and undertake the experiment. Now this was touched upon very briefly before Christmas, and we will be discussing it in detail next week again, so it's really important that we do understand these key words before we move on today and into next week. So, independent variable. My turn, independent variable. Your turn? Okay, so the independent variable is the factor in an experiment that the experiment changes. This variable is not influenced by any other factors in the experiment, but it causes change in other variables. So, put it simply, the independent variable is the cause of change in an experiment. Now that sounds quite complex, however we can just simplify it by explaining what the independent variable will be in our experiment. So in our experiment, the independent variable is the different types of sugar. Okay? That is the independent variable. That is what will change or cause change in the experiment. The different types of sugar will cause the change in the time it takes to dissolve. So our independent variable is the different types of sugar. What is our independent variable? Yes, the different types of sugar. Very good. Another type of variable is then our dependent variable. So we have an independent variable, which is the type of sugar that does not change. Our dependent variable then, these are variables that are changed by the independent variable and are called dependent. So it is dependent on the independent variable. The dependent variable is what is being studied and measured in the experiment. It's what changes as a result of the changes to the independent variable. So our independent variable is our sugar. Our dependent variable is the clearness of the water. The water will not change in terms of how transparent it is without the independent variable. Nothing will happen in this experiment without the sugar. Okay, so the sugar is something that does not change. Same amount of sugar, 2 teaspoons, into the water. The water is the dependent variable because that will change because of the sugar, or the independent variable as it is known as in this experiment. So the clearer the water, the more sugar has dissolved. So we've learned about our independent variable, which is sugar. We've learned about our dependent variable, which is the water. And now something that we have discussed before Christmas is fair testing. Okay, making sure the test is fair and is going to be as accurate as possible. So a quick recap on that, because this is something you will be doing next week when you're going to be creating your own fair test and designing your own experiment. So a fair test is a test which controls all but one variable when attempting to answer a scientific question. Only changing one variable allows the person conducting the test to know that no other variable has affected the results of the test. To help you remember how to conduct a fair test, learn the mnemonic. Okay, cows moo softly. My turn. Cows moo softly. Your turn. So this is going to help us keep our tests fair. So cows, C for cows, C for change. Change one thing, the independent variable. We are changing the sugar. 3 different types of sugar, that is what we're changing. Measure something, moo, M for moo, M for measure. Measure something, which is the dependent variable. We are measuring the clearness of water. So we are measuring how transparent water is. S for softly, S for same. So you keep everything else the same. They're the controlled variables. The amount of sugar, your 6 stirs, and the amount of water. So, once more, cows move softly. C for cows, C for change. Change one thing, change your independent variable, change the sugar. M for moo, M for measure. That is a dependent variable. You're going to be measuring or examining the clearness or transparency of the water. Finally, S for softly, S for same. Everything else except the sugar stays the same. So you change the sugar, but the amount of sugar stays the same. You have 6 stirs per type of sugar, and the amount of water stays the same. Okay. So before we go and do that experiment, we need to predict. We need to predict which sugar we think will dissolve the most. Now, I've chosen to do brown sugar, caster sugar, and icing sugar. And hopefully you'll be able to see inside here. You can see the icing sugar here is quite dense. It's almost floury, and you can't even really see the grains. I have my caster sugar, which we've experimented with before. And you can see the grains are there, and it is less dense than the icing sugar. Finally, I have my brown sugar, and you can clearly see the grains inside of there. They're quite large, they're quite thick. So you may have different sugars at home. If you do, then you can do your prediction based on that. If you don't, you can do your prediction based on mine. Now I will model my own prediction first. Just let me get my book. So, my prediction, I'm going to say, I predict the caster sugar will dissolve the quickest, because the granules, the little pieces of sugar, the teeny tiny pieces of sugar, are less dense, they're not as close together as the icing sugar, but are not as large as the brown sugar. So I think the size of the brown sugar is going to slow it down. I don't actually know that, I'm just predicting based on looking inside my different types of sugars. So I've said I predict the caster sugar will dissolve quickest because the granules are less dense than, I need to check my work, the icing sugar, but are not as large as the brown sugar granules. Okay, there is my prediction. You need to pause the video here and make your own prediction, either based on the sugars I have or the sugar you have at home. So we're ready to get started. We're going to do the experiment now. I'm going to model how to do it. Remember, hot water. You are not to do that on your own at home without an adult, please. So we're going to now do the experiment. So I'm going to get these pieces of paper out of the way. Have my types of sugar that you can just about see. I have my 3 beakers of hot water. It's not quite boiling water, it's actually just lukewarm water. So I've actually boiled the kettle and I let it cool down slightly, or you could just run it under a hot tap, but the hot tap in school wasn't working today, so I had to boil the water rather. I have my spoon, and I have my lovely red timer to time. So, how many spoons of sugar do I need to put in? Thank you, yes, 2. So I'm going to start with the icing sugar. So I'm going to put 2 spoons of icing sugar in. And My next step is to do 6 stirs. So 1, 2, 3, 4, 5, 6. After my 6 stirs, I start my timer. Okay. Doesn't seem to be dissolving. So, on my results sheet, I'm going to make a note of that. So I'll just get these out of the way for a second, and I will show you what to do on the results sheet. So my type of sugar was icing sugar. Spoonfuls, two spoonfuls, and 6 stirs, but after 20 seconds it had not started to dissolve. Now the comments here are to compare with the cold water, which I'll be doing very shortly. Okay, that's the icing sugar done. I can move that out of the way for the time being. Now let's get our next sugar up. So I have my next beaker of water. This time it's my caster sugar. So 2 spoons again and 6 stirs. Okay, 3, 4, 5, 6. Set my timer, go. Okay, a little bit left still to dissolve. Still a little bit. I'll zoom in slightly more for you. Okay, and I'm going to stop the timer. So I'll get out my results sheet again. This was my caster sugar. So 2 spoonfuls, and 6 stirs, and after 16 seconds it had dissolved. Okay, and my final type of sugar, sorry you could not see that, I will now show that to you. So you have icing sugar, caster sugar, number of spoonfuls, how many stirs, and a comment around the time. This comment, remember, is for the cold water, which we're going to do shortly. My final type of sugar is brown sugar. Okay, so I'll move this out of the way so it doesn't get wet. And I will get my last beaker up. Here it is, same amount of water. Everything does not change, they're controlled variables. 2 spoons of sugar. So 1 and 2. 6 stirs. 1, 2, 3, 4, 5, 6. Okay, making a mess of my table. Now you can actually see that this has sunk to the bottom. The brown sugar has sunk. Maybe it is quite heavy. I'm going to start my timer and see if it makes any difference. I'll just watch for a few seconds. Okay, it's not becoming transparent. The sugar has actually sunk to the bottom. So I'm going to just stop my timer here and make a note of that in my piece of paper. So I'm on my brown sugar, just to prove that I did everything the same. 2 spoonfuls and 6 stirs, and after 10 seconds most sugar had fallen to the bottom, and was not dissolving. Now remember, I've said you can do 2 more if you want because I've given you extra space, which is absolutely fine. Okay, there's my 3 done. You can do more if you like. I'm now going to do the exact same thing with my with my cold water. So I'm going to pause myself here and I will be back to you. So I am back with a much tidier desk and with 3 beakers of cold water this time. So we're going to conduct the exact same experiment, but we're just using cold water as a means of comparison. So off I go with my icing sugar. 2 spoons, 1 and 2. 6 stirs, 1, 2, 3, 4, 5, 6. Timer and go. Okay, again, it seems to be even slower than with the hot water. So I'm going to pause and just stop that. So I can say the cold water also did not dissolve the icing sugar, and in fact appeared to be even slower. So it's saturated faster. Okay, that's that done. Next one is my caster sugar. So I'll get rid of my icing sugar and get the caster sugar. Okay, 1, 2, 6 stirs, 1, 2, 3, 4, 5, and 6. That's my 6th stir, okay, ensuring it's a fair test. I will now set my timer. Okay, and off we go. Okay, it's definitely slower, because last time we said it took 16 seconds. Just watching it, nearly there. Okay, so I'm going to stop it there and I'll be able to make the comparison. So I can say here that the cold water slowed down the process. Again, sorry, really tight for space here. Of the caster sugar dissolving. Okay, and finally we must do our brown sugar. Okay, get up my last beaker, which is the brown sugar. Two spoons, 1, 2, 6 stirs, 2, 3, 4, 5, 6. Okay, again, you can see it's just sunk to the bottom. Just to ensure that everything is controlled, I'm going to set the timer. Okay, apologies, my camera just seemed to cut out there, but I did time it again and it had all sunk to the bottom, so I'm just going to make a comparison with the cold water. Cold water had no influence on the brown sugar dissolving either, so in comparison with the hot water. Okay, and the last thing I need to do is now write a conclusion. So in terms of recording for Seesaw, you have your do now, you have your prediction, you have your results sheet, and you will also have a conclusion. Okay, so your conclusion might be separate to mine. So I'm just going to write my own conclusion just to model it for you to see what the expectation is around you writing your own, and then you'll be able to go and do the experiment yourself as long as you have adult supervision for the hot water, as I keep saying, and then you'll be able to write the conclusion at the end. So, in conclusion, the castor sugar was the fastest to fully dissolve. All the sugars in cold water took longer to dissolve or did not dissolve at all. Okay, so that is simply my conclusion. I have my prediction, I have my do now, which was done on my sheet. I have my experiment results table, and I have my conclusion. Please upload all 4 elements to Seesaw if you have had the opportunity to complete the experiment. If not, you can still do the same around prediction and conclusion based on watching mine. Okay, so even if you do not get to do it yourself, you are able to do it as part of watching mine. Okay, thank you so much for your time. I hope you enjoyed Science Being Back, and we'll continue next week where you'll be designing your own experiment. Thank you.